Hello guys, welcome to Solving Solutions on Baran channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to show you how to create buffers around your digital elevation model. So this actually helps you to define zones around your elevation ranges. So we have a digital elevation model which we are trying to modify the symbology to something like this. So let's say we need about 4 or 3 classes, and then we have these to be the colors, right? Good. Apply and then OK. So we have our elevation values to range from 187 to 885, and then we have used this color scheme to represent it. So we want to now create what a buffer around this digital elevation model by creating what a range of value. So let's say we have this digital elevation model and then we want to analyze to know maybe there are some areas that are prone to flood, or maybe landslide, or maybe any other phenomena that we want to study. But let's say we want to use flood as the instance on today's tutorial. So most times it's always in the lower regions, right? Good. And then if you look at our digital elevation model based on the color scheme, you can see the higher regions are around 800, and then the lower regions, which are bluish in color, are around 187. So we want to create what a range that says, okay, values that range from, let's say, 100 to 150 or 200 have higher chances of getting flooded, right? Good. So the output raster will now return a binary raster that contains zeros and ones, whereby the zeros represent the other values that are not within 100 and 150, whereas the 1 represent the values that are within what 0 100 and 150, right? Good. So we have our digital elevation model. We come to raster. We go to raster calculator. Now from this raster calculator, we are going to build what the raster calculator expression. So we open a bracket. We include what our digital elevation model in it. So the first condition is that we want the value to be within 100 and 150, or let's say 100 and 200, right? Good. So we want to say the digital elevation model that is greater than or equal to 100, right? Good. So we have this. So we have greater than or equal to 100, then we close the bracket. Then we come to this operator and we open another bracket again. The digital elevation model, which will now be what the upper limit, right? Good. That is what less than or equal to, let's say we are using 200, right? Good. So we have created this range. This range now specifies that, okay, these elevation values that are within this range have higher chances of getting what flooded. So this helps us to create a buffer around what these elevation ranges. So we are going to save it to a file. So we click on browse. So let's call this flood underscore range. So let's call this flood range, right? Then we click on save. So it's a GeoTIFF, and then we leave every other thing as default as it is, and we click on OK. Good. So we have what our raster outputted, and then you can see the values from what 0 to 1, right? Good. And then from the color scheme, you can see that 1 represents the whitish area, which is this area, and then 0 represents what every other part, which is black, right? And then if we take this out, we are going to see now that it actually falls within that bluish region, which means that we're actually around 100 to 150, or maybe 100 to 200, because it falls within what this our bluish region, which has the elevation values around 187 up to maybe 200 or thereabout, right? Good. So what this create buffer around your digital elevation model does is that it helps you to determine areas that might get flooded if the water rises to what, or maybe above those values, right? Good. So within the range of 100 to maybe 150, we are using these values because they are closer to the water compared to maybe the data set you would have. Yours might be lower depending on what the data set you're having, right? Good. So this gives you, or this serves as a guide in your maybe productive application. Are we together? Good. So it helps you to determine what the area that might get flooded, maybe when the water level gets to those values that we have created, what the buffer, right? Good. So thanks for coming to class. We hope we have provided solution to this particular solving problem on how to create a buffer around a range of values of your digital elevation model to help you isolate, right? Good. To help you isolate some regions that are, or that will be prone to some phenomena. So we are going to see you on the next tutorial. Ensure you keep staying safe and have a very good time. Bye.